Okay, we are going to change the variables, and this will change the region of integration into another shape. This one is also not so complicated, so we may calculate this integral without changing the variable. You just have to, if you consider it as type 1, you have to write two double integrals, 0 to 1, 1 to 2. But if you consider it as type 2, then it will not be very complicated. It will be just one double integral. So let us calculate this integral by using change of variables. Use the transformation u is equal to y minus x, v is equal to y, to evaluate the integrals on the parallelogram R. I say D mostly for regions. We use D or R of vertices origin 1, 0, 2, 1, and 1, 1. So this is the line y is equal to x, and this is the line y is equal to x minus 1. So you may express this as y minus x is equal to minus 1, and this one becomes y minus x is equal to 0. So that is why we are choosing y minus x to be the variable, to be the new variable, and v is equal to y because you already have lines in appropriate place, like with respect to y-axis it is you don't need modification, let's say. So if you remember, for change of variables we need to calculate the Jacobian partial derivative of x with respect to u, partial derivative of x with respect to v, and then the same thing for y with respect to u, and then partial derivative of y with respect to v. This is Jacobian, and then we will replace everything in this expression in terms of u and v. So the a will be replaced by absolute value of Jacobian times du dv, and we have to choose the bounds appropriately. Y minus x is going to be u because y minus x is equal to u. So this region, okay, let me first figure out the bounds, then we may calculate the Jacobian and then calculate the integral. So this one is u is equal to 0, this one is u is equal to minus 1. So we can say the bounds for u is minus 1 to 0, and the bounds for v, it is same as y. Y coordinate is from 0 to 1. So this is the region. It becomes, this parallelogram transforms into a rectangle. Let me sketch it a little bit above. Let's say this is u, this is v. So it becomes u is minus 1 to 0, and v is, sorry, I misplaced minus 1, I should say somewhere here, minus 1 to 0, and v is 0 to 1. So it becomes a rectangle with this transformation, and double integrals over rectangles will be easy to calculate. Now let us calculate the Jacobian. We will need it in this expression. Partial derivative of x with respect to u. What is x in terms of u and v? U is equal to y minus x and v is equal to y. So you may replace, in the first expression, you may replace y with v. That will give us x is equal to v minus u and y is equal to v. X and y in terms of v and u is this. So partial derivative of x with respect to u is minus 1. With respect to v is 1. Partial derivative of y with respect to u is 0 because v is constant. Partial derivative of y with respect to v is 1. So this determinant is minus 1. So the double integral becomes, we replaced y minus x with u, so it became u. Absolute value of Jacobian is 1 du dv, and u is from minus 1 to 0, so the inner one, and then v is from 0 to 1. So we have to calculate this, which will be easy for you. So u squared over 2, the integral is with respect to u, is 1 to 0. This is the result of the inner integral, which is 0 minus 1 over 2. So the integral will be 0 to 1. The inner part is minus 1 over 2. Minus 1 over 2 dv. So this is minus v over 2 from 0 to 1. So it will give us minus 1 over 2. The result of the double integral is minus 1 over 2. Because u is negative, so, and it also depends on the function. As I said, you may consider it as type 2 region. If you consider it type 2 as type 2 region, you may also calculate this double integral without changing the variables. So let me calculate without changing the variables. It was something like this: y is equal to x, y is equal to x minus 1, y is equal to x, and this is 1. So this region. So considering it as type 2 region, I will express these in terms of x. So x is y plus 1. Y plus 1 is equal to x. And for this one, x is equal to y. So I can say x is between y and y plus 1. What about y? Y is between 0 and 1. Y is between 0 and 1. What was the integral? Y minus x, right? Y minus x. Type 2, so I will say dx dy. X is from y to y plus 1. It may take little bit longer compared to the solution, changing the variable. Y minus x, its integral with respect to x is going to be, let me write the inner part first. So it is going to be yx minus x squared over 2, yx minus x squared over 2, where x is from y to y plus 1. So this is going to be a polynomial function in terms of y. It will take some time to simplify the expression. Y times y plus 1 minus y plus 1 square over 2, and then substitute y square minus y square over 2. Let me simplify the expressions. What we will have if we simplify the expressions, you have y square plus y minus y square over 2 minus 2y over 2, which is y, minus 1 over 2, minus y square over 2, so it is minus y square over 2. So which expressions simplify each other? I have y minus y, they cancel each other. And we have y square minus y square over 2 minus y square over 2, they cancel each other. So we have only this 1 over 2. So the integral becomes, remember, it was 0 to 1. So it is 0 to 1. The inner part, the inner integral is minus 1 over 2, and then dy. So this is the result of this calculation will give us the same thing. So this is minus y over 2, y from 0 to 1, so you will get minus 1 over 2, the same result as we obtained by changing the variables. So the region is not very complicated. If you consider it as type 2, you don't have to split the integral into 2 or more. Please visit the website for a categorized list of my YouTube videos. It is given below in the definition of the video. Subscribe and like.